Hello and welcome to the fourth video of online trajectory generation for industrial robot with 3D camera training package. In this video we will interface and configure the robot with the ROS environment. In the previous video we configured our camera for ROS environment and installed necessary camera drivers and software. In this video we will install the robot drivers for ROS and configure the robot for our application. Here's our software and hardware infrastructure. We will be focusing on the robot side of this infrastructure now in this video. We will need the following software for our robot, which is the robot driver ROS package, and this package will be focusing on KUKA robots with the KUKA experimental package, which is the package we will be installing. We will also need to position and orient the camera base frame to robot base frame and interface the robot driver with object detection framework. We will start off by installing the drivers. We will get the KUKA experimental package from the GitHub repository, and this is basically the same procedure that we had on the previous video regarding the camera drivers. We will also install the missing dependencies we could possibly have, and then we will build the workspace using catkin make command. This is the same procedure that we saw in the previous video. We will first off need to specify our robot's IP address to the ROS operating system driver. We will take a look at where the IP address is configured in the KUKA experimental package by searching for the robot IP parameter in the controller configuration files. We can see that we need to specify the IP address in three different places, which are the hardware controllers and the move it configuration controllers. Here is the move it configuration file where we will specify our IP address. Next we will specify the camera position and orientation for our robot controller. We will need to add a specific line into the move it configuration launch file in order to position the camera base frame accordingly in our robot workspace. We will do this by adding a static transform from the robot's base frame to the camera's base frame. You will need to substitute the X, Y, and Z and roll pitch yaw parameters for your own. And next we will be verifying our robot driver installation. We're going to start the ROS core, and then we're going to start the robot driver nodelet. As we can see, the robot driver nodelet starts appropriately, and we also have our camera positioned accordingly. And we will be able to jog the robot in the simulation by grabbing onto the arrows and then clicking plan and execute. This will transfer the target coordinate system for our robot. And the robot moves accordingly to the simulation. The robot target coordinates are published to move group topic, which means that we are able to substitute stitch coordinates for work object coordinates, which we saw in the objects topic in the previous video. We will write a separate node that subscribes to the objects topic and then feed the stream to the robot controller. At this point we have installed robot drivers and configured the robot on ROS. This concludes our training package for module Online Trajectory Generation for Industrial Robot with 3D Camera. Thank you.